Good morning, viewers. Today on APES Channel 1, we will be discussing the high cost of high tech. As many of you know, we cannot have electronics, including your TV from which you are watching at home, without metals. But where do these come from, and where do they go? Once we're ready to upgrade to the newest and most advanced products. Let's hear from Chloe on extraction, use, and disposal of precious metals in electronics.
Thank you, Keisha. Today in my segment, Extraction, Use, and Disposal, I'll be discussing extraction procedures, uses of materials, and disposal. So which metals are most useful and how are they extracted? Gold, silver, platinum, palladium, rhodium, ruthenium, iridium, and osmium are all used in most circuit boards and displays and batteries of electronics, but gold, silver, and platinum are probably the most well-known and most common. Gold and silver both involve hard rock mining, which is also the mining style used for gems. Hard rock mining involves opening pits or underground mine tunnels to extract gold and silver from rock. Mining machinery is used to tunnel down parallel to ore deposits or perpendicular, depending on how veins run, vertically versus horizontally. Another common but less used in modern times is panning for gold along water supplies above gold reserves. Platinum is mined in a different way. Miners use explosives to break up the land and extract smaller particles of platinum, which may be scattered throughout a rock supply. To separate ore from other rock and debris, particles are crushed, then ran over a stream of air bubbles in water, which brings platinum to the surface of the water. Unfortunately, both of these methods cause scarring and damage to the Earth's surface. Once you dig up or explode rock, it is impossible to restore the land to its previous form. Are these extraction methods worth it? Well, technology producers seem to think so, since these three metals have many uses and are some of the best of their kinds. Gold is used in most circuit boards because it is very conductive and malleable and it does not tarnish. Silver is the best thermal and electrical conductor of any metal and is malleable, so it is commonly used on or in on-off switches and buttons. Since it is highly conductive, you do not need many contact points in order to allow the current to flow. Platinum enhances magnetic quality in hard drive storage disks, which allows for a larger magnetic field and more storage. It is also used to coat electrodes and is used to make fiberglass. Among these, many other metals have many other uses, so I cannot foresee electronic companies reducing metal use for any purpose other than to make products more durable and long-lasting. Speaking of replacing electronics, that leads me to my next point. Where exactly do electronics go when they serve their purpose, break, or become outdated? Most e-waste is pulled apart to extract these valuable metals and reusable parts, but the rest is mainly just tossed aside in landfills. Even recycling companies don't truly dispose of e-waste in a way that minimizes toxic leakage into the environment. Most of the time, these companies separate out and reuse metals, and the rest of the devices are trashed or sent to another country, such as India or China, to be dealt with by someone else. Well, that's all the time I have for today. Now on to Serena with environmental consequences.
Thanks, Chloe. I'm Serena, and today I'm going to talk about the environmental consequences of e-waste. Though most e-waste is produced by developed countries, it is disposed of by harmful informal recycling markets in countries like China, Pakistan, India, Vietnam, and the Philippines. The shredding, burning, and taking apart of these electronics releases harmful emissions, which are toxic chemicals that are not biodegradable. When e-waste goes into landfills, toxic chemicals are released, and toxic metals can leak into the groundwater, which can contaminate resources. This happens mostly in third world countries and affects people who are already struggling. In addition, when warmed up, e-waste releases toxins into the air, which damages our atmosphere. According to the UNEP, TV e-waste will double, computer e-waste will increase by 5 times, and cell phone e-waste by 18 times. This will be detrimental to our environment. If we want to protect the environment, we have to act now. Now, on to Amanda with environmental and social justice.
In Ghana, reportedly, mostly orphans 12 to 20 years old work in a slum burning discarded electronics that release toxic fumes into the air. Therefore, children are being closely affected by these toxic fumes and are especially at risk of lead poisoning. Combustion from burning e-waste creates fine particulate matter, which has been linked to pulmonary and cardiovascular disease. Now, if this isn't enough to change the way that we deal with our e-waste, then I don't know what can be done. And now on to Shamika with our solutions.
Thank you, Amanda. One way we can reduce this issue is by banning hazardous materials in electronics. This way, the amount of toxins released into the earth will decrease. Another way to solve this problem is by making a policy that requires the manufacturers to take back the products and recycle them properly. This will definitely help the environment and save many people from getting many diseases. Now, something we can all do to help reduce toxic waste is to support eco-friendly companies. Once we do this, the other companies who harm the environment will eventually lose their business and they will have two choices: either to shut down their business or start becoming eco-friendly. Thank you. Thank you for tuning into channel APES-1, and we'll see you next time.